Good morning. Hi. I just want to double check that Mr. Seagull's put the mic on. So if you can hear me, do a little bit of typing. You can hear me? Yeah, I think you can hear me. So, good morning, everyone. How excited are we? Just can someone good quick type? I can hear Mr. Seagull. You can hear Mr. Seagull. I think we can hear me. So, good morning, Lindsay, Irene, Isabel. I'm really excited. We are live with Explore Learning. I'm Mr. Seagull, but you can call me Bobby. So let's say a good morning to me. Good morning. 1, 2, 3. Good morning. Come on, let's do it a bit better. 1, 2, 3. Good morning. Yes, here we are. And we've got some, let's see who we've got this morning. We have Alexander joining us and his brother Gabriel. Welcome back. We have Shivan with his younger brother Sean, hopefully as well. We've got a few new people that I'm really excited to welcome to the Explore Learning family. We have the twins who are age 9, which is 3 squared, Kia and Misha. And we also have Hannah, age 9. Welcome to Explore Learning. So, what are we doing today? Maths, obviously. So I'm a school maths teacher. I'm the author of The Life-Changing Magic of Numbers, about how numbers and maths change my life. So I want numbers to change your life as well. And I'm also the presenter of the BBC TV series Monkman and Seagull's Genius Guide. And we've got an announcement. By next week, I'll be able to tell you when the new series is out. So I'm really excited. So I'm here with Explore Learning's Explore at Home. And we're supporting their mission to keep education going during these difficult times. And if you want to find out more about a free trial, go to explorelearning.co.uk. And we love social media. Ellie, age 6, Findian, Charlton, Casper and Southend. We all love social media. So can you, if you're enjoying the lesson, enjoying bits of homework, can you message us? Hashtag Maths with Bobby. We're on Twitter at Bobby_Seagull. I'm on Twitter, Instagram, TikTok, YouTube, and Facebook. If you want to follow me to find out more about maths, go to facebook.com/bobbyseagull. So facebook.com/bobbyseagull. Give me a like, and then you'll be able to keep up to date with all my maths activities. But also we're Explore Tutors on Twitter and Explore Learning_official. Hello, Bo. Good morning to you. We're very excited. So today is going to be about something, patterns and sequences. But before we do that, we always going to do a little maths mantra, yeah? The maths mantra. Here we go. So remember, people come to me and say, Mr. Seagull, I can't do maths. But Bo, we know people can do maths, can't we? Shivan, we know people can do maths. So Shivan, this is what we do. We put our hands up, Emily and Holly. 1, 2, 3, go. Yes, I can do maths. Yes, I can do maths. Yes, I can do maths. Come on, Gabriel and Alexander, let's do that together. Come on, 1, 2, 3, go. Yes, I can do maths. Yes, I can do maths. Yes, I can do maths. Thank you. We've got people from Aberdeen and Sophie. We're all ready to go. So what is today about? So today is week 5, patterns and sequences. And next week, we've got a special. Next week is actually going to be National Numeracy Day. So it's almost like World Book Day, but a national celebration of numbers. So we're doing a special lesson on how you can be smart with your money using maths. So that's National Numeracy Day next week. So the lesson is, for those who are new, we've got Able. The lesson only works 30 minutes of me teaching you a topic, working together, being interactive. And then a few minutes of thoughts of Mr. Seagull. Positive ideas on how you can think in a more constructive way about the way you think about life. And then normally I have a few questions from parents or adults or carers, and I'll try and support you there. Then we'll end the lesson with our maths rap. Hop loves the lessons. Hop is 8 years old, which is 2 times 2 times 2. There we go. So, we're about to start our lesson. Who is excited for some maths? Who is excited? Thomas, are you excited? Raj, are you excited? Come on. Yes, come on, give me an excitement. Yes, I'm ready for maths. So we're gonna get the party started. We're gonna get the maths party started. Yes, Shivan, we're gonna get it started. Here we go. Okay, so today's lesson is all about patterns and sequences, but we're gonna, Phoebe Neva, I like getting guests involved. And today, we're gonna go to the boxing ring. I'm gonna move this out of the way. I'm gonna move this out of the way. We're gonna go to the boxing ring, and I'll tell you why. Patterns and sequences are all about, I'm gonna move this way out of the way, about reacting to things. And boxers are quite good at reacting. They sometimes go up, sometimes they go down, sometimes they stay still. So let's get some boxing stuff on. I'm gonna get my boxing towel, got my boxing pad. Hold on. Got my boxing pad. Are you ready? Mr. Seagull is going to be your trainer today, yeah? Yes, I can do maths because today we're going to be looking at patterns and sequences. And in the sequences, things can go up, things can go down, they can stay the same, they can do anything. And boxers are people that have got to be nimble because in their game, you need to be able to go up, down, stay the same, move around. It's all about being nimble. So here we're going to go. So I'm going to do a sequence of punches. Okay. Firstly, I'm doing 1, 2, 3. 3 punches. Okay. And now 1, 2, 3, 4, 5, 6. 6 punches. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 punches, Bo. And the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 punches. We're getting ready. So let's have a look at that. We're going to start basic. We're going to move on. So I did 3 punches first of all, then 6 punches, then 9 punches, then 12 punches. Come on, where do you think we're going to end up after that? 3, 6, 9, 12. You can chat put in the box there. Come on, I'm waiting for you to give me instructions. How many punches do I need to do next? I've done 3, I've done 6, I've done 9, I've done 12. Come on, I need to know the next thing in my sequence for my training session. What do you reckon? So we've done 3, then 6, then 9, then 12. I can hear you shouting through the screens. Come on, Callum, tell me what it is. It is 15. Yes, I think I heard Shivan, Kia, and Misha shout it through the screen. It's 15. 15, well done. So the reason why that was 15 was because we're going up in threes. 3, 6, 9, 12. We're going up in threes. Let's try another one. Tony says, do I do boxing? Yes, I do box fit. I do like my boxing. So, well done. Lots of great answers. Uma, Ellie, all got it spot on. So, let's do the next one. So, we're going to do another one. So, we're going to go down this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 punches. Then, 1, 2, 3, 4, 5, 6, 7, 8. Now, 1, 2, 3, 4, 5, 6. And the next one is 1, 2, 3, 4. So what is the mathematical pattern there? So we go from 10, 8, 6, 4. So 10, 8, 6, 4. What's next now? So we've done some sequences in boxing. We've done 10, 8, 6, 4. So where are we going next? Come on. What's my last bit? I need to know. Come on. You have to let me know. Come on. I'm ready for this session. But you need to tell me how many more punches. So we've gone 10, 8, 6, 4. Zach, what do you reckon it is, Zach? Rinky's got it. It's going down in twos. So this is 10, 8, 6, 4, 2. Well done. So that's an easy one. But now, I'm gonna test you. I think you're saying, Mr. Seagull, I know these routines, these sequences are easy. Let's try another one. Who would have thought, Mr. Seagull, you got the boxing training this morning going on? Boxing training. Okay, so this time, what we're going to do is a new sequence. A bit more difficult. We're going to go 1. Then we're going to go 1, 2. Okay? Then we're doing 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh. What is this going to be? So it goes 1. Then it goes 2. Then it goes 4. Then it goes 7 and 11. So this one is a bit trickier. I'm going to actually put this up for you, boys and girls, as a poll. I want to see if you've got this one. So have a look. Let me see if I've got it correct before I publish it. Yes. So have a look at this. It's coming up on your screen. It goes 1, 2, 4, 7, 11. What is next? Come on. The boxer needs to get involved. I'm ready for this, but I need you to tell me what's next. Come on. So you got 1, then 2, then 4, then 7, then 11. So this is slightly different. So Amisha, this is slightly different this time. So I'm going to poll up on the screen. You got option 13, 14, 15 or 16. So we are doing patterns and sequences if you just joined us. And the reason I'm getting all the boxing is that boxes, they involve sequences and patterns because sometimes they'll stay up, sometimes they'll stay down, sometimes they'll go sideways. And patterns mathematically in sequences are similar. Things go up, down or stall. Okay, Lara says she's not quite sure what's going on. So let's look at the answer. So I'm going to show you the results. So this is the closest poll we've ever had. It shows you it's not an easy question. We've got half the people saying it's 13, 14 or 15, but we've got just about a marginal leader at 16. So let's have a look. So the answer was actually, I'm going to show you the poll. It was 16. It was 16. And I'm going to show you why. So 1 to 2, it goes up by, you add 1. We add 1. Then 2 to 4, we add 2. We add 2. Then 4 to 7, we add 3. You're starting to spot a pattern here. Then 7 to 11, we add 4. So each time, we're going up a bit further. We're adding 1, then we're adding 2, then we're adding 3, then we're adding 4. So the last one we add, 5. 11 plus 5 is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. There we go. So that was, so the poll should be in your Facebook screen if you look up. So that is a mathematical sequence. And again, these sequences, you've got to keep your wits about you because sometimes they go up in a certain number, sometimes they go down, sometimes they get smaller. Sometimes actually you find that they get larger and larger and larger and larger. The gaps get bigger. So you've got to really keep your brain thinking. So we'll do a couple more. And then I've got a really exciting part of the lesson. Even more exciting than boxing and mathematics. So I think I'm tired. Let's get in. Okay. So imagine now, I'm not going to do these boxes because I'm going to be here a long while. So imagine we have, so I started doing some boxing when I went to university. It's more box fit. I don't want to get my head damaged because it's non-contact boxing. There you go. So imagine we've got 3, then 6, then 12, then 24. 3, and I'm not going to do 24 punches because I will be exhausted. So 3, then 6, then 12, then 24. What do you reckon is next? So going 3, then 6, then 12, then 24. What do you reckon is next? 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So it's going to be, if you look, it's going up by 3, by 6, by 12. You can look at that. But actually, Meter's got it right. We're doubling. 3 to 6, we're doubling, yeah? And then 6 to 12, we're doubling again. Then 12 to 24, we're doubling again. Okay, do you think I'm going to sit there and do double number of 24 boxing punches? Not today, but I can tell you the answer. The answer, Ratisha's correct. She says it's 48. And if we double that, the next one, we get 48 times 2, which is 96. Yes, it's good. I got a few people on the ball. Johnson Nathaniel also says we're doubling it. So we're doubling the sequence. We can double things. We'll look at another one. I want to do one more with you. Let's have a look at another sequence. And I want to see if I can test you on one. So imagine we have this one here. This one is a bit trickier, okay? This one's a bit trickier. So 31. Okay, this one, I'm not going to be doing 31 punches, okay? Even for you, as much as I love maths, I'm not going to do 31 punches. So 31, then 25. So 31, then 25. This looks a bit strange. Then 35. Now you're thinking, where's this going? Then 29. What on earth is this boxer doing? He's a mad boxer. Then 39. Then 33. What is this boxer doing? What could he possibly do? He's crazy, this boxer. He's nuts. What is this boxer doing? I'm not happy with this sequence. What is he doing? He's doing 31, then 25, then 35, 29, then 39, 33. I have no idea what he's doing. It makes no sense. Makes no sense. Let's see if we can get what he's doing. Okay, so this one's a bit trickier. So in this particular one, I'm going to see if I've got a poll on this as well. So this one here, firstly, he goes down by 6, yeah? Down by 6. Then he goes up by 10. 25 to 35, okay. Then he goes down by 6 again, from 35 to 29. Then he goes up by 10 again. What is up with this boxer? Then he goes down by 6 again. So can you see in this sequence, it's strange. It's going down by 6, up by 10. Down by 6, up by 10. Down by 6. Then the next one's going to be up by 10 again. It's going to be 43. That is a sneaky little boxer. Sneaky guy, sneaky guy. So Sam, you got it right. It goes down by 6 and up by 10. So with sequences, you've got to be very careful about thinking where it's going. Is it doubling? Is it adding a number? Is it getting smaller? Someone's saying, I'm the boxer. That's true. That's true. I should tell myself off. You shouldn't trick them with boxing things. Okay, I'm really sorry. Don't trick them because sequences are really important and need to understand it. I'm sure, okay, I promise I'll be good. Okay, I've told myself off. I'll be good. Okay, so, Ala, we're going to do a problem on this. So we're going to do a quick poll. And it should be open. Have a look at this. So it goes 15. This is the last one before we move on to a new topic. A new topic. And I'm really excited about this topic today. So have a look at this topic. So, it says 15. Have a look. Is it doubling? Is it tripling? 15, 26, 25. And I'll put it up on the board for those of you who can't see the Facebook poll. 36, 35. So have a look at this, boys and girls. Have a look at this poll. Have a look at this. So Karen looks like she's on it. Karen looks like she's on it. Let's see, we've got Shivan, Gabriel Alexander. Do you know what's going on? So if you can't see the poll, it's on the board here. It says 15, 26, 25, 36, 35. What's happening here? Kia and Misha, any ideas? Who else do we have? Hannah, welcome today. Hannah, do you have an idea? Let's have a look. So, I think a lot of you are on the ball here. So, Jane, Black, and Toadie, they say what you do is you add 11 minus 1. Let's have a look. Let's have a look. Karen Jacobs, right. So, you add 11, 15 to 26. Then you minus 1. Then we add 11. Then you minus 1. Then we add 11 again. And we get 46. So, that is the sequence for this particular one. Leah, well done. Congratulations, that's good. I'm going to close the poll now. Thank you for your contributions, everyone. Casper, well done as well. So we're adding 11. So, again, with sequences, remember, we've got the boxer. The boxer, it's me. Let me get my boxing pads. The key thing is, be nimble. Be ready to move because the sequences could go up, could go down, could stall a bit, up and down. So you just got to be ready, Eva. You've got to be ready for all of these things, okay? Okay, so now we're going to move on to the next topic. I'm done with boxing for today. I'm done. It's time to now focus on something else. Okay, it's we're about halfway, more than halfway through. So someone said they're not sure if you get it. If you're not sure about this, go back later on to Facebook or YouTube and watch the video again. And then it'll give you more time to catch up. So do that. So, here we are, an apple. You got an apple here. Am I going to eat it? Yes, but not right now. So, what I want you to do is, can you ever think, imagine this apple here, and I sliced it in half along the middle, not down. Normally we cut it down vertically. Imagine we cut it along the middle. What happens? So I'm going to leave this as a question for you. What do you think might happen if you cut it? What does it look like? What would the pattern be? Let's have a look. So we have, let's have a look. So we have an apple and we slice it along the middle. What do you think might happen? So the boxer, we left the boxer, but the boxer now needs some nutrition. What do you reckon will happen? So you get the apple, slice it in half down the middle. What do you reckon? Normally I'd get you to draw this and show me in the class, but what do you reckon? Describe it. There's some sort of pattern going on. What do you reckon? I'm going to show you now. I'm going to cut this apple. I'm going to cut this really tasty, delicious apple. So we've got this apple here. What do you reckon? It will cut my hand. I hope not. Someone says 2 halves. So you could slice it along the middle and make 2 halves. Leah thinks, oh, Leah's got a very smart idea. Leah says it looks like a flower. Leah might be quite close to the truth. We says a seed in each side, says Joshua. Let's see what else we have. Someone says, I think it's Samantha says there's a circle. 2 halves. A lot of people saying it's 2 halves, but if you split it down the middle, they're 2 halves. But if you split it along the horizontal, I think Leah's idea was quite smart. So let's have a go and let's have a look. So I'm going to slice it. I'm going to slice it, and I hope this works. I haven't tried it. I haven't tried it today. I'm going to slice this apple. I am actually cutting it. Hold on. I need to do more boxing training because I'm finding it difficult to slice this apple. Oh my gosh. This is really difficult. And I don't want to cut my hand live on Facebook. So again, I'm on Facebook. It's facebook.com/bobbyseagull. So if you want to follow me. Oh yes, I think we've got it. I think we've got it. Oh God, my hands are going to get sticky now. Okay, so I'm going to get my towel. If you look here, boys and girls. So some of you said it looks like a flower. Oh wow, Justin says a hexagon. So if you look here closely, can you see there's 5 bits? There's 5 bits. Can you see? 1, 2, 3, 4, 5 seeds. So an apple is split into 5 parts. That's amazing. 5 parts. 5 parts. Bo, did you get that? And Ismail says it looks like a star. It does a little bit, doesn't it? And I'm going to tell you why. So thank you so much for your contributions to the answer. So it has 5 seeds. Have a look at this. So the apple's there. 1, 2, 3, 4, 5. 5 seeds. And what you find is this 5 has a reason behind it. And we're going to look into why. So I'm going to get a video clip up for you. Hopefully it'll work. We're going to get a video clip up for you. Hold on, give me a second. So the question that I want you to think about is, why is it 5 seeds? Why is it 5 seeds? Like, why, what's the relevance of 5 seeds? So let us play the clip. Hold on. Let me get it for you. So 5. Like, why is it not 4? Why is it not 1? Why is it not 10? Why is it not an even number? So let me get this for you. Here we are. So have a watch of this. That's me, Mr. Seagull, and you're going to see a clip on this. Let's have a watch. So pay attention. Hopefully the sound will work.
And myself have always searched for patterns in the world in an attempt to find logic and order within randomness and chaos. Take this flower. The number of petals in each row is the sum of the preceding 2. It's called a Fibonacci sequence. Discovered in 1202 by Italian Leonardo Fibonacci, whilst contemplating the mathematics of breeding rabbits, he noted a sequence formed through constantly adding together the previous 2 numbers. As the numbers get bigger and bigger, the ratio between each of the values trends to 1.618. It's a special...
So, we'll go back. So you'd have seen the number 5 crop up. So let's have a look at that sequence there. So it started off at 0. You don't have to have the 0, but it's there. Then it went 1, 1, 2, 3, 5, and then 8, and then 13. If I can get 13 there. So can you see that sequence? 0, 1, 1, 2, 3, 5, 8, 13. And this is called a Fibonacci sequence. I'm going to write that for you. Fib, F-I-B. Let me get the spelling correct. Maths is always good to get the spelling. Fibonacci. And this is something new. And let me consult my dictionary. Fibonacci. Let's have a look at the dictionary. What does it say in the dictionary? So Fibonacci, if I go to F, the mathematical dictionary. Let me get it out. So it says here, for Fibonacci, the Fibonacci sequence is one of the most famous formulas in mathematics. Each number in the sequence is the sum of the previous 2 that are before it. So each number in the sequence is the sum of the previous two before it. So if you look at it, if you add 0 and 1, you get 1. If you add 1 and 1, you get 2. If you add 1 and 2, you get 3. If you add 3 and 5, you get 8. So this sequence here is called the Fibonacci, and it's named after a man called Leonardo of Pisa. You know the Leaning Tower of Pisa? It's not going to fall, hopefully, but I hope it doesn't. The Leaning Tower of Pisa, he's from there in Italy, about 1200 that year, so about 820 years ago. And he came up with this pattern. And he noticed that this pattern was everywhere in nature. And the way nature grows is actually grows in this particular pattern. Things will have one leaf, then another leaf, then 2, then 3, then 5. And if you think about it, have you ever seen a 4-leafed clover? A 4-leafed clover. They do exist, but they're rare. A 4-leafed clover. And the reason is, often things will go up in 1, 1, 2, 3, 5. And we have the apple here, and we saw the 5. It exists because of the Fibonacci sequence. And I'm going to show you, I'm going to carry on this clip for you. Let's have a look. I'm going to carry on. So I want to show you where this goes, and this is quite magical.
A special number that since the beginning of time has been hidden in plain sight all around us, embedded in nature and fundamental to life itself. The Greeks knew of this number and had a name for it. They called it the golden ratio. Picturing a curve, a golden spiral if you will, growing at a constant rate of 1.618 every turn, suddenly reveals its startling influence in the world around us, from how a nautilus shell grows, to the destructive power of a hurricane, or the movement of a distant galaxy. The golden ratio is even found in ancient structures as humans harness its power for the purpose of beauty, from famous works of art to the corporate logos and symbols that dominate our lives. I'm even talking to you right now in the golden ratio, all based on a number you can find in a flower. Now, isn't that just incredible?
So, boys and girls, I think that's remarkable, isn't it? I think that's remarkable. Can you see that? The golden ratio. And this is all to do with Fibonacci. So Fibonacci is a new thing. Again, when you look at an apple, you would think it might have 4 or 2, an even number of pips. But it has 5 because of Fibonacci. And that Fibonacci sequence, we can see it throughout the world. Again, remember in that clip, it talked about a few things. Let's see if it's here. So we can see it in sunflower seeds. You can see it in cauliflowers. You can see it in shells. You can see it in the spiral of universe. You can see it in DNA. And someone's asking me, Raj, what is the golden ratio? And that's a really great question. So you know what the golden ratio is? If you divide the number, let's say 3 divided by 2. So do 3 divided by 2, you get 1.5. If you do 5 divided by 3, you get 1.67. If you do 8 divided by 5, you get 1.6. What happens is as we get larger with the sequence here, so you know this Fibonacci sequence, again, this is amazing, boys and girls. This is the power of mathematics. So we have 5, then 8, then 13. What's the next number? After 13, it's 13 plus 8 is 21. Then after 21, again, you add the 2 numbers next to it. 13 plus 21 is 34. If we keep dividing the numbers next to each other, we get a number that's called the golden ratio. And Edward says he knows this. It's amazing, isn't it, though? The golden ratio. Even in our DNA, we see there are 21 and 34 strands of a particular DNA. And Sarah Ling says it's about 1.618. 1.618. So this golden ratio exists everywhere in nature. And it's amazing. And there are some mathematicians that say, oh, but we're just finding a pattern that doesn't really exist. But it's amazing. For example, we have 2 knuckles, or 2 hands, 5 fingers. That these numbers here, 1, 1, 2, 3, 5, 8, 13, exist everywhere. So it's at 1.618. And that is called the golden ratio. And this is a beautiful sequence, beautiful sequence. So Phoebe says she doesn't get it. So let's just recap. Let's recap where we are. And I'm going to do a quick rap about this, of course. A quick rap. So my quick rap. So quick glasses. Time for the rap. Okay, the rap is 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. So do that again. 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. Let's do it one more time. And then Irene, I'm going to explain the sequence again. So it goes 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. So let's get Bobby back. Let's get Bobby back. The rapper has to go. So if you look at the sequence, I'll look at it properly again because this is totally new. We've done sequences this morning with a boxer going up, down, adding numbers, multiplying. But now, let's look at this sequence. Again, you often start 0. We'll put 1 there. So you get 1, then 1. And then what we do, Irene, is, if you can see that, we add the 2 numbers together and we get 2. Then we add those 2 numbers, Irene. Then you get 3. Then we add those 2 together, 2 and 3, you get 5. Then we add 3 and 5 together and we get 8. And then we add 5 and 8, we get 13, Zach. So when, I think someone was asking me what happens. So again, my rap was 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. So you keep adding up the numbers next to each other. And the beautiful thing mathematically was that when you divide the numbers next to each other, as the numbers get bigger and bigger, for example, it go 21, 34, and you can do this for me, 55, it keeps, is that correct? Yeah. 34, 55, yeah, it keeps adding up, and this turns into 1.618. And that is sequences for today. Sequences. So you can see sequences can help us work out when things go up, when things go down, when things stay the same. Or you can look at things like this, Shivan and Sean, the golden ratio, about 1.618, and you see it everywhere, in universes, in famous paintings, a wonderful structure. So, where are we now? It's time for Thoughts of Mr. Seagull. Thoughts of Mr. Seagull. So this is going to be related. So someone's saying I'm going a bit fast. There's a lot of content, and what I would say is you can always watch the video back. Always watch it back. So you got your own time. You can watch it straight after. So, Thoughts of Mr. Seagull. So I want you to take a deep breath and then breathe out. Deep breath in and breathe out. Okay, so this is going to be related to a scene from the BBC program on Monday. So on Monday, my brain was scanned. My brain was scanned for a program called the Great British Intelligence Test. And they wanted to find out, is my brain any different to other people? And we're going to see it. Chris, we're going to see it. We're going to show you the scene here. Hold on, let me get up the scene. So this is on Monday. And let me bring it up. Let me bring it up. Here we go. So have a go. And our lesson, our Thought of Mr. Seagull's related. So have a listen.
Scanned.
This will take about 25 minutes.
Experts at the University of Edinburgh have been studying thousands of brains, searching for anything that might make some cleverer or faster than others.
Okay, we're just going to start scanning and it's going to get very noisy.
Are clever brains bigger? Are they wired differently?
Are you all right there?
Revealing the secrets of Bobby's intelligence is Dr. Simon Cox.
Your brain volume is extremely average, if not a little bit lower than average.
Lower than average?
A little bit.
Small brain?
That's correct, yes.
Oh, Bobby. Clearly, when it comes to intelligence, brain size isn't everything. But is there something in Bobby?
So, did you see my face? Did you see my face when they said your brain is smaller? I thought, oh, is there something special? Actually, they said there's nothing special about my brain. And this is where the thought comes today. It's not about the physical size of your brain. I think it's a lot what goes on here. It's your attitude and mindset. Do you remember a few weeks ago, you may have seen this before, I had these two guys here. We know these two guys, Ant and Dec. And imagine these were just two fictional characters. And one of them thinks that they can do maths and one thinks they can't. And there's one difference between the two people. It's their mindset. It's not about the brain, it's about your mindset. If you're someone that says, oh, maths is difficult, I haven't got a maths brain, oh, I can't cook, oh, I can't dance, oh, I can't draw, then you have a fixed mindset. Whereas, if you're someone with a growth mindset, then you think, oh, actually, if I work hard at things, I can improve. And that's the thought of Mr. Seagull today. It's your mindset. It's your mindset that makes a difference. Not the size of your brain, not what you got going on there. It's your heart and what you think about that. And you can actually find this on BBC iPlayer. It's called the Great British Intelligence Test. So if you look at it there, you can find it there. So let me try and find what other things are going on. So we've got a few messages. We've got a few messages coming up. Let's have a look. So this is the program on BBC iPlayer. It's called the Great British Intelligence Test. If you have a look on BBC iPlayer, you'll be able to find it there. And then next week, I'll be able to give you an announcement when my new TV series comes out. So it's Monkman and Seagull's Genius Adventures. And that's coming out very soon. So I've got a few announcements to make. So also on that, if you want to see me being very positive, again, if you go to my Facebook, facebook.com/bobbyseagull, do follow me there. And you find all my positivity. So it's facebook.com/bobbyseagull. And one of the things that I'd love you to look at is my TED talk. And it's called The Magic of Numbers, Why Everyone Loves Maths. Because you can see, I don't think it's about your brain. I think it's about your attitude, your heart. Do you really want something? And in my talk, it's worth watching, maybe even after this, it's about how actually your mindset is the most important thing to being good at maths, science, English, cooking, dancing. All things need a positive mindset. So we have a question coming from a parent. So the question is, let's have a look. So the question was, we're finding it hard to get through all the activities set by the school. What should we do? And that's a great question, because there are lots of things that you should be doing, lots of activities. And I would say, first thing is, perhaps speak to your school. Maybe speak to your form teacher if you're in secondary, or if you're in primary school, speak to your class teacher. And then what I would say is, don't put too much pressure on yourself. Because normally in school, you got lessons, the teacher will check up on your work, they'll come around the classroom. Whereas now you're at home and it's more difficult for that to happen. So I would say, don't worry too much. Don't put too much pressure. Try and do as much as you can. But if you don't make as much progress as you want, it's okay. We are in unusual circumstances. And again, that's why we put on these live lessons for you. That's why we've got Explore at Home, the free online sessions, because we want you to try and be supported during these difficult times. So again, someone said they follow me on Facebook. So again, facebook.com/bobbyseagull. Again, I'm on Twitter, Instagram, YouTube @Bobby_Seagull, and I'm on TikTok. Let me bring back the banner. So we're about to look at the last few messages. I'll bring this back here. Okay, so let's see what else is going on. So obviously Explore at Home has this new, it's really sparkling, it's a great website. It's not a new website, but let me bring up the main scene so you can see it clearly. So there you go. So we've got my TED Talk I'd love you to see. So again, #mathswithbobby, @Bobby_Seagull on Twitter, Instagram, and on Facebook you can find me, YouTube as well. We're at Explore Tutors, and we're at Explore Learning_official, and we'd love to see you share your videos of you doing lessons. Ellie says it's her birthday this Saturday, so happy birthday to Ellie. Sam wants to know where you can buy my book. So Sam, let me show you a copy of my book. So Sam, if you actually go to, again, if you check Twitter or Instagram or my Facebook, a lot of details are there. So I've got, it's the same book. This is a hardcover. This is the paperback. It's called The Life-Changing Magic of Numbers. And it's pretty much similar to my TED Talk. And it shows you why all of us can do maths. You can see my face, smiley face, smiley face. So that's the paperback or the hardback as well. So you can get this on Amazon. It's called The Life-Changing Magic of Numbers. Happy birthday to Leah, who turns 9. who turns 9 on Saturday. Lots of birthdays. And actually, one other thing I'd love you to get involved. If you love maths, if you love learning, come along on Saturday. Let's get this back. Come along on Saturday. So I do family-friendly quizzes. So I do family-friendly quizzes. There's maths. There's primary school maths questions. There's charades. I act out. You can see I'm crazy with my boxing routine. I do a music round. I do a pictures round. And even if you're a fan of Strictly, some of the Strictly dancers do charades for my quiz. So it's called Quiz for NHS. If you go and check my Twitter, my Facebook, my YouTube, all details there. And we have lots of members from Explore Learning that take part. So that's wonderful. So please do join in on that on Saturday. So let's have a look. We're going to look at the rap we learned today. And we're also going to have a look at a few shout outs towards the end. So the rap today was about Fibonacci. Remember Fibonacci went 1, 1. I'll pause there for a second. So Fibonacci goes 1, 1, 2, 3, 5, 8, 13. 5, 8, 13. Oh, Irene asked me a question. What school do I teach at? So Irene, I teach in East London. So I teach at a school called Little Ilford School. It's very convenient for me because it only takes me about 20 minutes to walk there in the morning. So it's very handy, Little Ilford School. So if any of my students are there, hello. What else do we have? A few more shout outs. So Shazana, Mohammed, thank you. Zach wants a shout out. Ellie's birthday on Saturday. So join me for my quiz on Saturday. So let's do the rap from today before the concluding rap and some more shout outs. So rap today, remember, was, let's get the glasses for the rap. So remember it went 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. 1, 1, 2, 3. That starts Fibonacci. 5, 8, 13. Sequences to be seen. And that's Fibonacci, the golden ratio. We see it everywhere. So I'm going to do a few shout outs before our final maths wrap. So thank you, Phoebe and Neva. You've been wonderful. Mia and Leon. Leah's birthday. Join me on Saturday for Quiz for NHS. Mandeep. My toy's name, Irene's asking me. Where's my toy? Ah, here. This is called Manny the Lion. And he's my positive mascot for University Challenge. So he gives me a little confidence boost when I need it. Mayuri wants a shout out. Hello, Mayuri. So I've been really excited. You've been wonderful. We're Explore Learning. Explore Learning, we're all about Amir, about fearlessness. Remember, people look at my brain and go, Bobby, is your brain naturally smart? We're not. It's not about being naturally smart. At Explore, it's all about being fearless, trying things out. And a few of you today looked at the golden ratio and said, that's quite tricky. I'm not sure what's going on. But if you're fearless, you keep going, you come back, maybe watch the video again, maybe speak to parents, check out YouTube videos, check out Explore Learning's website, and try and keep delving in, because maths is all about your attitude. Remember, we need, if you look at these two guys here, we need growth mindset, not fixed mindset. We need growth mindset. That's what we need. And all of us can do that. So thank you all so much. So we are back on Friday with Key Stage 3. So if you want to progress with sequences and we do some fun stuff, next week on Wednesday is National Numeracy Day. So that's going to be amazing. We're going to have new people join us for that particular day. And again, make sure you go to explorelearning.co.uk. You can find a free trial about how to book an online session with us. So please do that. So Harry, we're about to end. We're in stoppage time. And stoppage time means it's time for our wrap. So Alexander, Gabriel, let's do this. Sean, Shivan, Hannah's new, Kia, Misha, Bianca. Let's get involved with our maths wrap. So here we go. 1, 2, 3, go. Yes, I can do maths. Yes, I can do maths. Yes, I can do maths. 2 more times. Siloam, let's do it. 3, 2, 1, go. Dilara, yes, I can do maths. Yes, I can do maths. Yes, I can do maths. And the very last time, let's give it a 3, a 2, a 1. 1, 2, 3, go. Yes, I can do maths. Yes, I can do maths. Yes, I can do maths. Thank you so much. Thank you, Bo. Thank you, Beatrice. Thank you, foster carer Karen. Zach, you've all been wonderful today. Happy birthday. And again, if you tweet me, Instagram me, Facebook comment at Bobby_Seagull or facebook.com/BobbySeagull. Let me know any shout outs. I can do a shout out for you. Even send you a personal video message saying, be happy, be mathematical. Thank you so much, and I'll see you all very soon. Thank you. Bye-bye.